Hello. You've just finished putting the solutions into the freezer, I presume? Yes? Well, now we shall go over the finer details that are going on at a atomical level within the solution at this moment. So here I've drawn a glass of water, much like the one I've put in the freezer, except for one key element is missing. There is no solute. Now look at the structure of this. Each water molecule consists of 2 hydrogen and 1 oxygen atom. Now, the very interesting and peculiar thing about the water molecule is that it is polar, bipolar, which means that there are 2 different poles on the molecule creating 2 different charges, which means that one side is more negatively charged than the other side, and one side is more positively charged than the other side. Now, the remarkable thing about water is that because it is bipolar, it breaks apart the solutes into ions and bonds to them and separates them and creates a saturated solution. So when I add, for instance, let's say salt, NaCl, which I will represent by these 2 colors, salt has a positive charge, which means it will be more attracted to a negatively charged source, which in this case would be the oxygen side of the water molecule. So the sodium, when placed in the solution, would break apart and bond to the water right here. Now this is the same for all of these. So when you look at it, you basically just added these little ions to the water molecule. Now, likewise with the chlorine atom, an ion, when it breaks apart, the chlorine is a negatively charged, so it would be more attracted to a positively charged ion, like the hydrogen side of the molecule. So when you take the chlorine ion that is in solution and it bonds with the water in here, you can see that, like the sodium, it bonds to the water and it creates an even bigger molecule or group of atoms. So when you look at this, it becomes pretty crowded. Now, according to colligative properties, the properties of a solution will change when added a solute. So when I take water and I add table salt, it will disassociate with each other and it will bond with the water, and you will have all these free-floating ions everywhere. Now it says that because of this, the freezing point is lowered and the boiling point is raised. Now, if you think about it, the science behind this is pretty sound. I mean, so you see this and you see how it's surrounded by sodium and chlorine ions. So it's getting pretty crowded in there. It's not just water molecules anymore. It's got sodium ions and chlorine ions. So I've created a couple of examples for you. In dealing with a freezing point, it's much like dancing with your girlfriend. It's very hard to dance with your girlfriend, and in this case become a solid, like water, and get close together and form the hexagonal shape and become a solid, when you have a tiny head guy in between you. I mean, it's hard to dance with her if there's a big giant guy with a tiny head in between the two. So it's like the water is trying to form a solid, but at this given circumstances, which would be 0 degrees Celsius, it can't form a solid because there are all these ions in the way. So you have to get the solution even colder to get the water molecules to finally freeze. Now the same goes for boiling. I mean, take this for example. It's hard enough to lift a piano by yourself, but when you've got to lift a chlorine and a sodium ion as well, it's even harder. So you have the water molecules trying to evaporate into the air, but at the given circumstances, which is 100 degrees Celsius, you don't have enough energy to become a gas and lift those molecules out of solution because you've got sodium and chlorine hitching on to each other. So at 100 degrees Celsius, pure water will evaporate. But when you add a solute like sodium, and when you add a solute like table salt, and it disassociates and forms sodium and chlorine, it's very hard to lift out the water molecule is bonded with sodium and chlorine when you've got to carry, or when you've got the weight and the sheer bulk of the sodium and chlorine. Now also, this is proven mathematically.